This conference will now be recorded.
Hello. Hello.
Sir.
Okay. Yeah. Good afternoon, everybody. So we'll go for SDA. I said we'll go for SDA. Okay. Now I will create one. Okay. On free. Class 8, isn't it? Let me open the data set and have a look at it.
Sir, whether it will be class 7, I think so.
It will be class 7, huh?
Yes, sir, because in the first session we have done KNN, so we have given the example of KNN only. So
Okay.
in the name.
So that was, I think that actually it was class 7. Okay. Anyway, no problem. So it will be class 7. Okay. Sure. Apples and oranges, no? Apples and oranges, apples and oranges. So this is basically the thing. Wait, let me have a look at the data set. So what is actually the feature over here? The feature is the weight and the so here we have the data set. Very good. Now what I have to do next? Okay, fine. So here the feature is actually the weight and the size, right? And the target is basically the target is actually what? The class column, isn't it?
Yes, sir.
So how many data set is there? Okay. Okay. So total, I think there is only 40 data set. Near about 40. Very good. Near about 40. Now we have to classify this with the help of, or we have to do the classification with the help of support vector machine. Theory of support vector machine is also highly clear to everybody. There is no issue with that. No problem. Okay. Okay. Now let's move ahead. Let's move ahead. First of all, we will read the data. Import matplotlib.pyqt. Okay, and data equal to pd dot rule underscore csv. What was the name of the data set? APPLES and oranges. APPLES and oranges. Okay, very good. APPLES underscore and underscore dot csv. Weight, size, and class. Okay, weight, size, and class. So here we read the data set basically. Data dot shape 40,3. Data dot shape na. Then data dot info. Let us see the info of this data set. Data frame में है और one column is integer, one column is float, and the other column is basically string. Integer and string na. Okay. Data.describe. So this is basically the data. Count is of weight is also 40 and the size is also 40. So I hope is null dot sum. Weight 0, size 0, class 0, entity type 0. That's it. Okay. Now I will just go for the scatter plot. Scatter plot. What will be X label? What will be X label? It will be weight, and Y label will be size, suppose. Weight. Let's run this. Awesome. Very nice. Very nice. Very good. Now, SNS count it. Size, weight, class, comma, let me see. Oh, are equal number of orange and equal number of apple. Just have a look. Look at this data set. Here, no problem of class imbalance. No problem of class imbalance. Okay, getting the point. So on x-axis, I'm going to take the x equal to data dot I log. I'll take all the rows and I will take the 0 and 1. Starting from 0 colon. Now I will take all the rows except minus 1. Right? So if I print here x, so I'm taking x instead. Okay, that's it. And on y-axis, I will take data dot I log. I will take all the rows and I will take only the last column. Let me see and print y and see. Okay, apples, oranges, apples, oranges, apples, oranges. Okay, perfect. Perfect. That's it. Done. Okay, that's it. Done. Now. Okay, perfect. No problem till here. Just have a look at the code and please tell me. Please confirm, please. It is very simple. And here we have random state equal to 0. Very small data set, not required. So in testing we are having 30% and in training we are having what? 70%. Okay, so run this cell. I think it will cause a mistake because here I have small x and small y. Small x and small y. Small x, small y. Run this. Run this. Run this. Okay, now let me check what is actually na? So 28 should be in the training part and x test 12 should be in the testing part. Okay, perfect. Perfect. So this is basically done, complete. Okay. Now This is a non-linear data set, as you can see from the scatter plot. As you can see from the scatter plot, any doubt? So I have to use RBF. So from sklearn import CLF equal to SVC, kernel equal to RBF, radial basis function. Okay, now with the help of this model, I will train the model. See, I just trained the model. See, my model is trained. Now I told in SVC I have to take the value of C. Okay, getting the point? I have to take the value of C. C equal to 1.0. To take the value. Okay, run this. Okay, perfect. The model is straight. Now, now yesterday somebody asked me one question, sir, what is the use of that score? What is the use of the score function? Okay, so see here I'm using this score function. Okay, X test and Y test will be capital. Oh wow, giving very low accuracy. It's giving very low accuracy. This is not done. Let's see. It's giving 100% accuracy. 37% accuracy. 37% accuracy. 0. 100% accuracy. It's giving 100% accuracy. The data set is very small, na? It's giving 1. The value is giving 1. Very small data set. So it's a very easy for what to say. CLF dot predict X test. If I run this, it's giving me apple, oranges. See, it's giving me the output. Okay, so whether it is giving the correct output or not, let us validate first. Okay, let us validate. Getting the point? Let us validate. Validate. So here, suppose if I take like this one, weight is 69 and if the size is 4.39, then it's an orange. Okay, or suppose let me take this, weight is 67 and size is 4.7, then it's an orange. 67 4.7, right? 67 comma 4.7, then it must come orange. It is giving orange. See, it's giving orange. Now if I classify here, suppose 73 and 5.68, 73 and 5.68, then apple. 73 5.68, na, it should get apple. It's giving apple. It's giving a very nice accuracy. The data set is small and it's very easy to learn. Okay, that's why it's giving. See, giving very nice prediction. SVM. I told you SVM is a very powerful algorithm. You know, just have a look. Just have a look and you tell me if you face any problem, any sort of problem, just tell me.
So can we check for any unknown value? Like it is, yes. So you are taken from the data set only this value 73, 5.68. So yes. Once can we check for any unknown value? Like
yes, you tell me. Yeah, see, Darshan, I trained the model. Okay, and here I just validated the model to see whether it is working or not. Okay, it's working perfectly. Now you tell me the value. I will put it up here. You tell me the value.
Sir, 71.5.
71.5.
Sir, comma, sir, 4.37.
4.37. Apple.
Okay, sir.
Apple.
Hello,
I
sir.
just validated my model to see whether it is working or not, or whether it is giving correct prediction or not. That was my motto. Like this one. 69 and 4.76. 69, 4.76. 69. See, it's giving orange. So I validated. My model is working 100% correct. Okay, now you tell me the number of values. That value I will take and it will give a prediction for an unknown one. That is actually called testing, basically.
Hello, sir.
Yes, Rohit, tell me.
Sir, in 30 number line, the SBC bracket kernel equal to RBF and C equal to 1.0. Sir, what is the meaning of that?
What is the meaning of that? I created the model, Rohit, from sklearn.sbm import is
Yes,
BC.
sir.
Okay, this is the model. I created
Yes,
the
sir.
model. Here, since it is a non-linear data, see, here we can see it's a non-linear, right? We basically did what? Equal to R.
Sir,
Or see, for non-linear data set, kernel is RBF. Okay, even if the data set is linear, okay, then this method will not be applied, or it will be very easier for kernel to classify that. So even if you remove this SBC, still it is giving me 100% accuracy. See, if the data set is non-linear, then well and good. For that, kernel RBF is going to work. But if the data set is linear, you will say, sir, there is some clusters like what to say. One cluster something like this and one cluster something that means more or less orange or apple is means what already separated. Okay, so you can say that the data set is linear, sir. Let it be. Okay, then for non-linear this will work, for linear it will be more better. Okay, yeah, that doesn't mean if the data set is linear, then kernel is going to give you a poor prediction. No.
Sir, and the C value 1.0 means one cluster.
One.
Okay, sir.
Okay, what is C in SVM? I told na, C is actually the penalty parameter. It is actually the penalty parameter.
Okay,
means
sir,
penalty parameter of the error term basically. Okay, means you can consider it as the degree of correct classification. Okay, if you give a greater value of C na, means there is no way that SVM optimizer can misclassify any point. Okay, but for a smaller value,
okay, sir. Okay,
this
sir.
is the smaller value na. I gave one na. Darshan?
Yes,
So
sir.
I gave the value of C as 1.0 na. Small.
Yes, sir. Yes, sir.
Okay, but if you give the smaller value, means you are actually allowed to at least some degree of freedom, you can say. Okay, getting the point.
Yes, sir. Got it, sir.
So C value I have given 1. Okay, sometimes C value can be 100 also, it can be 1000 also. So if the smaller value means C optimizer means SVM optimizer for smaller C value. If the value of C is small, then SVM optimizer is doing what? SVM optimizer is actually allowing at least some degree of freedom to meet the best hyperplane. Means optimizer is actually allowing भाई तू अपना खुद का hyperplane खोज ले, अच्छा एक hyperplane खोज ले जिससे तू अच्छा क्लासिफाई कर सकेगा अगर C का वैल्यू स्मॉलर है तो. Getting the point? This is basically the thing. I've taken 1.0, right? So SVM is this one. This is SVM. Now I will open that yesterday's class, means class JS class 6. Here it was decision tree. Here we did decision tree. Wait, let me copy the decision tree code. Let me copy this decision tree code. I'll copy this decision tree. SVM is giving very good, well and good. Okay. And now here we have xtrain comma ytrain. Xtrain comma ytrain. Okay, xtrain comma ytrain. I run this. Okay, decision tree classifier, it's completed. Okay, now with the help of this classifier, I will test the score. What is the classifier? The classifier is DTC underscore CLF score. See, it is also giving 100% accuracy. Decision tree. Data set is very simple, na? It is very simple. Okay, it's very simple. Getting the point? Is it clear to everybody?
Sir, can we use kernel value over there in decision tree?
Nah. Decision tree you cannot use kernel value. Decision tree basically it is based on two parameters. One is actually the information gain and the other one is Gini index. Okay, so here we are using information gain. Information gain. You cannot use kernel over here. See, I have done one trick. This is the data set, na? I have copied the whole data set. Means the 40 code I have copied. This 40, okay, and I have pasted it once again. See, again I have pasted it. See, I have copied this and I have pasted it here. See what happened. I'm copying it from here. Okay, I'm copying this data set and I'm pasting it again. So my data set is doubled. Okay, see, double. Okay, now let us run this. Now from starting, let's see. So now see, the data set shape is 80,3. Now just have a look at this. Okay, increased, data set increased, and now see 40, 40, 80. Here my support vector machine is actually decreasing. See, it's decreasing, the accuracy is decreasing basically. The accuracy is decreasing. But for decision tree, the accuracy is 100%. Here decision tree is giving 100% accuracy. Decision tree is giving 100% accuracy. But here in these types of data, see our what to say, support vector machine is more or less it is not giving up to the mark. It's 85% accuracy. Okay, 85% accuracy. If I remove these values, will it affect? No, it's not affecting. Same. It's not affecting. Kernel equal to linear. Will it affect? See, now when it's linear, then it's working. See, it's linear, it's working. A linear data set, linear classification, it's working. But for RBF, it is failing. RBF failed. Okay, because here RBF is not required. Getting the point? It is for non-linear separation. Here, most of the majority of the data is totally linearly separated. So we are using kernel equal to linear. So that's it. Now it's giving 100% accuracy. Getting the point? But I'm not in any mood to do all this. Okay. Okay, leave it as it is. Leave the data set till 40 itself, and here see, now again it has decreased. Now it's working perfect. 40 na? 40. Okay, now it's working perfect. See, that's it, done. So decision tree classifier is also giving 100% accuracy, and here it is also giving 100% accuracy. Got it?
Yes, sir.
Okay, so this is actually out what is about SVM support vector machine. About SVM support vector machine. Now, do anybody has any doubt in support vector machine? Okay, chalo, no problem, chalo. So this is perfectly completed, done. चलो हटाओ, इसका प्रॉब्लम हटाते हैं हम लोग, ये हमारा टोटली सॉल्व. नाउ नेक्स्ट टॉपिक. So more or less we have done a lot of algorithms, isn't it? We have done a lot of algorithms. So I'm sending this JS class 7. I'm sending this. I've already sent the data set, isn't it? JS class 7. Tomorrow we will start our project. Okay, tomorrow we will start our project. Chalo, given, that's it. Now, next topic, our next topic will be dimensionality reduction. What will be our next topic? Our next topic is going to be dimensionality reduction. What is going to be the next topic? Dimensionality reduction. Can anybody tell me anything about dimensionality reduction? Do anybody has any idea what is dimensionality reduction? What is dimensionality reduction? नाम से क्या पता चल रहा है? नाम से
The dimension कोई भी डेटा सेट का या उसका मतलब डायमेंशन को रिड्यूस करना, मींस नाम से तो वही लग रहा है.
Exactly. तो सेम चीज एकदम सही बोला आपने. Dimensionality reduction is basically what? Reducing.
Sir, means dimensionality means suppose we are giving the input and features column are we are trying to reduce.
We are trying to reduce the features, the number of features. Okay, but one more thing, if the number of feature reduces, okay, if the number of feature reduces, then what will happen? The data might what to say, the whatever the
मशीन
data
का जो प्रेडिक्शन का परफॉर्मेंस है सर वो रिड्यूस हो सकता है, बिकॉज हम लोग को मशीन को फीचर्स देना चाहिए उतना ही, मतलब हम लोग को मतलब हम लोग का मोटिव मशीन लर्निंग का ये भी होता है कि ज्यादा से ज्यादा फीचर्स मिलना भी चाहिए जिससे वो अच्छे से ट्रेन हो सके और प्रेडिक्ट कर सके.
Very good. But Darshan said that the machine should get enough features so that it gets well trained, right? But I will say that Darshan, if the feature is enough, okay, then the machine may also suffer, or the model must also suffer from overfitting. The model might also suffer from overfitting. Am I right or wrong?
Yes sir, that can also happen. But sir अगर फीचर्स कम होगा तो सर अंडर फिटिंग भी हो सकता है.
फीचर्स कम होगा तो अंडर फिटिंग भी हो सकता है, ठीक है. फीचर्स कम होगा तो अंडर फिटिंग भी हो सकता है. वेरी गुड. बट when we are preparing or when we are working on a data set और a supervised data set, जब हम लोग वर्क कर रहे हैं, ठीक है, तो बेसिकली हमारा डेटा सेट जो है वो कुछ इस तरीके से ही प्रिपेयर किया जाता है जिससे हमारा क्या हो सके, वो मैक्सिमम इंफॉर्मेशन मशीन को दे सके, कन्वे कर सके. राइट और रॉन्ग? टेल मी. ऑब्वियसली राइट. सो हियर डायमेंशनैलिटी मींस हमको जब बुक दिया जाता है तो बुक में बेसिकली क्या होता है, हमको वो सिलेबस दे दिया जाता है कि भाई तुमको ये सिलेबस से पढ़ना है और इतना सिलेबस तुम्हारे एग्जाम में आएगा, और दैट इज ऑलरेडी प्रेजेंट इन आवर बुक, और एल्स वी डू व्हाट, वी बाय अनदर बुक. So whenever we work on a data set, we basically look whether the data set has got a relevant feature or not. whether the data set has got a relevant feature, yes or no. If the data set has got relevant features, then we for look for क्या उसमें एडिशनल फीचर तो नहीं है, और अगर एडिशनल फीचर है तो क्या वो हमारा डायमेंशन को इंक्रीज कर रहा है, ऑब्वियसली डायमेंशन को इंक्रीज कर रहा है. नाउ वेदर माय मॉडल इज सफरिंग फ्रॉम ओवरफिटिंग, यस और नो. दिस इज द थिंग. सो डायमेंशनैलिटी रिडक्शन इज बेसिकली द नेक्स्ट पार्ट. क्या बोल रहा है? रिड्यूस डेटा फ्रॉम 2D to 1D. ये इसको कहते हैं डेटा कंप्रेशन. Data compression. Here we have x1 centimeter and here we have x2 centimeter, x axis and y axis, right? So neither we are going for x1, neither we are going for x2, we are going for this particular line, this particular green line. Actually this particular green line we are going for, trying to reduce the dimension of the data. कुछ समझ में आ रहा है इससे? क्या बोल रहा है? Data compression, reducing data from 2D to 1D. Reducing the data from 2D to 1D. समझ में आ रहा है? थोड़ा बहुत तो समझ में आ रहा है. लिटिल बिट. Okay, little bit you are understanding na? Okay, chalo. Now let me understand, look at the just PPT and let me understand in a bit, in a simple English. Simple English I will say that the number of input variables जो data set में हमारा होता है उसको हम लोग क्या कहते हैं? उसको कहते हैं features. Okay, और फीचर जो होता है वही हमारा रिफर करता है क्या? डायमेंशनैलिटी. बिकॉज टारगेट कॉलम तो सिर्फ एक कॉलम होता है, ओनली वन कॉलम इज टारगेट. So the number of input variables or features for a data set is referred to as dimensionality. So dimensionality reduction actually refers to the technique of reducing the number of features in the data set, or we can say reducing the number of input variables in a data set. Right? Now question might arise, sir, why we do so? Why we reduce the dimension? Let me explain. If we have more input features, okay, so more input feature often makes a predictive modeling task more challenging. Means it actually makes the model more complex and thus models suffer from overfitting. Okay, models suffer from overfitting. So this is basically called curse of dimensionality. मतलब दर्शन के पास एक बुक था तो उसने वो बुक ही पूरा पढ़ डाला, वो सिलेबस से नहीं पढ़ा. बुक में 20 चैप्टर उसने नहीं पढ़ा, ठीक है, 20 चैप्टर जो है वो पूरा पढ़ डाला उसने, लेकिन सिलेबस में तो सिर्फ 7 चैप्टर्स आने वाले थे. he had studied extra 13 chapters. Okay, he has suffered from overfitting, right? If he after reading 20 chapters, if he thinks that he will score 100% marks or 95%, that is not possible. Maybe he can score 60 to 65% marks. Okay, so similarly, often more features often makes a model more predictive model more challenging. Means this is actually called the curse of dimensionality, which makes the model suffer from overfit. इसको कहते हैं curse of dimensionality. अच्छा लगता है जैसे भाई डायमेंशन ज्यादा रहेगा तो हमारा मॉडल अच्छे से ट्रेन होगा, बट सेम टाइम दिस आल्सो हैज एन एडवर्स इफेक्ट ऑन द मॉडल. So higher dimension or higher dimension statistics and dimensionality reduction technique is often used for data visualization. Basically. Getting the point? Now this one x2 and this is x. Just have a look at this. Data compression, basically data compression. क्या बोला जा रहा है? We understood that large number of input features can cause poor performance for the machine learning algorithm. Dimensionality reduction is a concerned study which reduces the number of input features. अब dimensionality reduction methods जो होता है इसमें बहुत सारे methods involved रहते हैं, like feature selection, how to select the features. This is some linear algebra methods. It occupies some linear, or it combines some linear algebra methods and some other projection methods. Okay, other projection methods. Now the performance of machine learning algorithm actually degrades with too many input variables. We know, But if your data is represented by rows and column in a CSV file or an Excel file, okay, then the input variables are basically the columns that are fed into the model to predict the large variable or to predict the target variable, right? And these input variables or the columns are called features, right? And here the features we are going to reduce. So we can consider these columns as a data representing dimension, yes or no? Or we can consider this as n-dimensional feature. Can we consider these columns as n-dimensional feature? Yes. And can we consider the rows as data points in space? Data points in space. Okay, that also we can say. So dimensionality reduction refers to the technique of reducing the number of input features in training data. Okay, so higher dimensionality means there are lots and lots of input variable. Okay, and fewer input dimension means what? It often means fewer parameters or a simple structure of a machine learning model. Simple structure of the machine learning model.
सर मेरा एक क्वेश्चन है यहाँ पे. Sir, like just now you have told that हम लोग मतलब dimensionality reduction means basically reduce number of features in training data from the training data. मतलब train test split करने के बाद ही हम लोग ये करते हैं. तो सर अगर ट्रेनिंग डेटा से हटा रहे हो, हम लोग जब टेस्ट करेंगे, अगर एक्स टेस्ट और वाई टेस्ट, अगर एक्स टेस्ट में अगर सर वो फीचर्स मतलब टेस्ट में तो रहेगा, फिर हम लोग जो डिवाइड किए ट्रेन टेस्ट स्प्लिट में, तो टेस्ट में तो वो फीचर्स रहेगा.
नहीं. देखिए दर्शक हम लोग पहले कोई भी डेटा सेट अगर एक लेते हैं तो वो डेटा सेट को क्या करते हैं, हम लोग उसको रैंडमली डिवाइड करते हैं. तो वी डोंट नो बेसिकली वेयर इट इज गोइंग फॉर मींस व्हाट वी कैन से बेसिकली where means our actually what to say, which part is going to training part and which part is going to testing part, we don't know. Basically after random division only we do that.
नहीं सर, वो तो बेसिकली रोज हो गया कि हम लोग कौन सा रोज ट्रेन में जाएगा टेस्ट में जाएगा, वो नहीं. हम लोग बेसिकली तो हम लोग को फीचर्स रिड्यूस करते हैं. मतलब कॉलम्स हटाना. तो अगर हम लोग उसको ट्रेन से हटा रहे हैं, आप जैसा आपने अभी बोला, वी रिड्यूस इट फ्रॉम द ट्रेनिंग डेटा सेट. कॉलम्स को अगर हम लोग ट्रेन से हटा रहे हैं तो हम लोग को सर उसको तो टेस्ट से भी हटाना पड़ेगा. जो टेस्ट है एक्स ट्रेन और एक्स टेस्ट में डिवाइड हुआ है, तो अगर हम लोग एक्स ट्रेन से अगर हम लोग कॉलम हटा रहे हैं तो एक्स टेस्ट से भी तो हटाना पड़ेगा. वरना अगर हम लोग एक्स टेस्ट अगर हम लोग प्रेडिक्ट कर रहे हैं एक्स टेस्ट में, तो सर वो तो वो फीचर्स को आइडेंटिफाई नहीं करेगा हम लोग, क्योंकि वो फीचर्स ट्रेन में तो दिए ही नहीं है.
देखिए अगर मॉडल हमारा ओवरफिटिंग होगा, ठीक है, मैं बता रहा हूं आपको, अगर हमारा मॉडल ओवरफिटिंग हो रहा है, ठीक है ना, इफ आवर मॉडल इज गेटिंग ओवरफिटेड, तो मॉडल हमारा ओवरफिट दर्शन कब होता है, कब हमारा मॉडल ओवरफिट होता है?
ट्रेन का ज्यादा होता है.
हाँ ना जब भी ओवरफिट होगा तो ओवरफिट तो हमारा ट्रेनिंग डेटा सेट से होगा ना.
यस सर.
अगर ओवरफिट हो जाएगा ट्रेनिंग डेटा पे, तो देयरफॉर इट मे नॉट परफॉर्म वेल ऑन द टेस्टिंग डेटा और न्यू डेटा.
यस सर.
ठीक है. तो न्यू इनपुट जो हमारा है, न्यू इनपुट जो है, जैसे हमारा डायमेंशन को अगर हम लोग रिड्यूस कर देंगे, ठीक है, और उसके बाद जो हमको आउटपुट बेसिकली मिल रहा है, ठीक है, डायमेंशन को रिड्यूस करने के बाद, ठीक है, तो बेसिकली उसी से हम लोग मॉडल को ट्रेन कर रहे हैं, राइट. वी आर एक्चुअली ट्रेनिंग द मॉडल, बट from the new input data or from the new data which we are going for the testing, उससे आप क्यों रिमूव करिएगा?
Yes sir, got it.
Getting the point? Our overfitting is basically occurring when? Our overfitting तब occur कर रहा है जब हम लोग उसको क्या कर रहे हैं? It's likely to overfit the training data set ना, and therefore if the overfitting occurs on the training data, then it will not perform well on the new data. Okay, so यहाँ पर desired case क्या है? So ये desire to have a generalized model or a model which generalizes well on the input data with few parameters or few input variables, जिसको हम लोग क्या कह सकते हैं, लीनियर मॉडल भी कह सकते हैं, राइट. जहां पर क्या होता है, हमारा नंबर ऑफ इनपुट्स एंड आवर डिग्री ऑफ फ्रीडम ऑफ द मॉडल आर क्लोजली रिलेटेड. व्हाट इज डिग्री ऑफ फ्रीडम? डिग्री ऑफ फ्रीडम बेसिकली क्या होता है? डिग्री ऑफ फ्रीडम थोड़ा देर पहले बताया ना, द रोज क्या बोला मैंने, फ्यूअर डायमेंशन और फ्यूअर इनपुट डायमेंशन, okay, or fewer input parameters or simple structure in the model, machine learning model is actually referred to as the degree of freedom, right? So a model with too many degree of freedom is likely to overfit the training data set, and therefore it may not perform well on the training data, or sorry, on the test data, right? So dimensionality reduction जो है वो ट्रेनिंग डेटा पे हम लोग परफॉर्म करेंगे only when our data is modeled correctly, okay. It is performed after data cleaning and data scaling, okay, and before training a model. Dimensionality reduction is actually performed before training a model. Getting the point? Before training a model. Getting the point? Now any dimensionality reduction which we are actually performing on training data. Now I am coming to your question, Darshan. See, ठीक है, मैं बोला हूं कि ईच एंड एवरी डाउट आपका एकदम क्लियर कर देंगे, हम एकदम 100% क्लियर कर देंगे, मैंने बोला था, ठीक है, देखिएगा आपका डाउट क्लियर होता है। इफ यू हैव परफॉर्म्ड एनी डायमेंशनैलिटी रिडक्शन ऑन ट्रेनिंग डेटा, then that dimensionality reduction must also be performed on new data, right? And that new data is basically what? Either it is a validation data or test data, or the data when making a prediction with the final model. So any dimensionality reduction performed on training data must also be performed on new data. That new data can be anything. It can be test data, it can be validation data, and data that we basically use during prediction for the final model. Got the point? Getting the point? Getting the point, Darshan? No problem. Rohit? No problem?
No problem, sir.
Okay. Now, so there are lots and lots of techniques for dimensionality reduction. Lots and lots of techniques for dimensionality reduction. The first method I will tell, there is a feature selection method. Feature selection. It is the most common feature selection technique. Means feature selection technique. To which features to keep and which features to delete basically is called feature selection mode. Means removing irrelevant feature that does not help a model to predict. That does not help a model to predict is basically we call what? We call it as a feature selection method. So this is the first method. Okay, getting the point? The second method is basically called matrix factorization. Matrix factorization. What is matrix factorization? It is a technique from linear algebra, I said, for dimensionality reduction. Here matrix factorization method can be used to reduce the dataset matrix. Okay, डेटासेट से जो हम लोग मैट्रिक्स फॉर्म करेंगे वो मैट्रिक्स को बेसिकली रिड्यूस करेंगे। कैसे? यहाँ पर हमको दो चीज जानना पड़ता है, या हमको एक जानना पड़ता है हमको आइगन डिकम्पोजिशन, आइगन वैल्यू और आइगन वेक्टर, याद है? आइगन वैल्यू, आइगन वेक्टर. So these two things are basically applied, okay, in order to reduce the dimension of the dataset. To reduce the dimension of the dataset. This is also a approach. This is also a approach. Okay, eigenvector, eigenvalue. Now if you want to establish this matrix factorization, then you have to learn one algorithm, and that algorithm is basically called PCA, principal component analysis. PCA, principal component analysis. Okay, principal component analysis. The most common approach to dimensionality reduction is called PCA, principal component analysis. The principal component analysis, इसको हम डिलीट करते हैं. Okay, PCA, ये है हमारा डायमेंशनैलिटी रिडक्शन टेक्निक. ये है हमारा डायमेंशनैलिटी रिडक्शन टेक्निक. ये आइगन वैल्यू, आइगन वेक्टर पे पूरा डिपेंडेंट है. Got it? Any doubt with this? Tell me. Any doubt with this?
No, sir.
No problem. Now Now प्रिंसिपल कंपोनेंट एनालिसिस, प्रिंसिपल कंपोनेंट एनालिसिस पीसीए का एक ट्यूटोरियल मेरे पास बेसिकली है, ठीक है, वो ट्यूटोरियल मैं अभी ओपन कर रहा हूं, राइट, ठीक है। इसको मैं अगर थोड़ा ट्यूटोरियल से पढ़ाऊंगा तो ज्यादा अच्छा लगेगा, आप लोग को बेहतर समझ पाओगे, ठीक है। पीपीटी में तो रहता ही है, ठीक है, okay, but I will teach you this from very what to say, a sophisticated thing, okay. Just have a look. I had a tutorial, I made all these tutorials for you only. Okay, see, I'm giving you. Okay, just have a look at this. Just have a look at this tutorial. Principal component analysis. Okay, principal component analysis. So principal component analysis, what they are trying to say, principal component analysis is actually a unsupervised learning algorithm, na? We don't have anything to do with target, so it is an actually unsupervised, we have only to do with features. So unsupervised learning algorithm that is used for dimensionality reduction in machine learning. So it is actually a statistical process that converts the correlated features. कोरिलेटेड फीचर देखिएगा, मैंने पहले ही बोला था कि अगर टू फीचर्स अगर कोरिलेटेड होता है तो हम लोग उसको नहीं रखेंगे, भाई, बिकॉज दे आर शेयरिंग द सेम इंफॉर्मेशन, they are nothing providing extra for the model, they are sharing the same information, so two correlated models cannot be kept. So it is actually a statistical process that converts the correlated feature into a set of linearly uncorrelated feature with the help of orthogonal transformation. Orthogonal transformation, and these new transformed features are called principal components. Principal component. So it is one of the most popular tool that is used in exploratory data analysis and predictive modeling. Okay, so PCA, as you can see, it can be used in PCA. Basically, it actually tries to find the lower dimension from a higher dimension. Okay, lower dimension it is going to find. It can be used during image processing. It can be used for movie recommender system. It is used to optimize the power allocation in various communication channels, and all these things are basically its terms or its uses, basically. Getting the point? Okay, now just have a look at this. Some common terms basically you with which PCA algorithm is actually associated. Like the first one is dimensionality. Dimensionality is basically what? It refers to the number of features. Refers to the number of features or variables that are basically present in the given data set. Just a second. I think I'm having some network issue. Just a second. Have a read this. Okay, see, dimensionality, it is called dimensionality. So the number of features or variable present in the data set. Correlation, how strongly two variables are related with each other. So if one changes, the other variable also gets changed. The correlation values actually ranges from -1 to +1. -1 occurs if variables are inversely proportional to each other. +1 indicates that the variables are directly proportional to each other. मतलब एक होता है नेगेटिव कोरिलेशन, एक होता है पॉजिटिव कोरिलेशन, ठीक है। जीरो होने से नो कोरिलेशन। यहाँ पर ऑर्थोगोनल इट डिफाइंस दैट वेरिएबल्स आर नॉट कोरिलेटेड टू ईच अदर एंड हेंस कोरिलेशन बिटवीन द पेयर वेरिएबल इज जीरो, दैट इज कॉल्ड ऑर्थोगोनल, राइट। तो मैंने थोड़ा देर पहले आप लोगों को क्या पढ़ाया कि पीसीए एक्चुअली इट इज द प्रोसेस ऑफ डायमेंशनैलिटी रिडक्शन इन एन ऑर्थोगोनल वे. Means uncorrelated feature with the help of orthogonal transformation. Means not a single feature is correlated. Basically. Okay. Not a single feature is correlated. Getting the point? Now, eigenvector. If there is a square matrix M and a non-zero vector V is given, then V will be eigenvector if AV is a scalar multiple of V. Remember, eigenvector, eigenvalue, ये बहुत सिंपल है, ऐसा कुछ नहीं है. आइगन वेक्टर हम लोग बहुत सिंपली, बहुत इजीली हम लोग पढ़े थे मैथमेटिक्स में, याद है? आइगन वेक्टर, रिमेंबर? आइगन वेक्टर, आइगन वैल्यू, आइगन वेक्टर्स इन, रिमेंबर? Isn't it? So this is a very, using finding the determinant, we have to find out the determinant. Yes. Okay, means we have, if you need to find the eigenvalue and eigenvector for a matrix A, then what we have to do? We have to find the determinant of the matrix. We have to find the determinant of the matrix, right? Remember, eigenvector, if we consider a square matrix of n by n, okay, n by n, and if X is a non-trivial column, it's a non-trivial vector solution column or vector, right? Then we will do what? A multiplied by X equal to lambda X, where lambda is basically a scalar, remember? Scalar, and X is the eigenvector of matrix. You just have to go through the mathematics a bit, huh? You will understand. It's very simple, because I don't want to go into that mathematics basically, you know. Getting the point? I'm not going that solution of eigenvalues and eigenvector problems and solutions. ठीक है, क्योंकि वो हम लोग को बेसिकली पता है, आप लोगों को थोड़ा सा रिवीजन देना होगा, मुझे मालूम है. ठीक है, थोड़ा सा रिवीजन देना पड़ेगा. फर्स्ट वी हैव टू फाइंड द डिटरमिनेंट ऑफ A. Okay, then we have to find the eigenvalue of the kth power of A. Remember? Okay, then we have to transpose a conjugate transpose, right? All these things were present ना, you just थोड़ा सा देख लीजिएगा, ठीक है, बुक्स वगैरह थोड़ा देख लीजिए, कोई दिक्कत नहीं है. सो ये था बेसिकली हमारा पीसीए को लेकर. पीसीए, नाउ पीसीए नाउ PCA, principal component analysis, I told it's a unsupervised, it's also non-parametric, okay, a technique that is used for dimensionality reduction in machine learning. Okay, now PCA से बेसिकली क्या होता है? We actually filter noisy data sets. Basically. We filter noisy data set. Okay, filter noisy data set basically. Getting the point? Okay, noisy data set. And this eigenvector and eigenvalue are actually the measures that actually quantify the direction and magnitude of the variation. Basically. Okay, getting the point? Any doubt?
Sir.
No problem? No problem? Okay, now. Just have a look at this particular figure. Have a look at this particular figure. Now, the principal component analysis is a unsupervised technique of reducing the dimension. So here see, it minimizes, and also remember that when we are actually removing the feature, that means there might also be an information loss, but PCA helps to restore information loss, means it minimizes information loss. It helps us to find the most significant feature in a data set and make the data easy for plotting in 2D and 3D. Just have a look. PCA actually helps in, just have a look at this particular. The first arrow that you are seeing is actually the PC1, principal component 1, and the second arrow that you can see is basically PC2, principal component 2. Okay, means here we can see, or we have several points plotted in 2D plane. See that red dots. These are points plotted in 2D plane. Okay, and there are two principal components. There are two principal components. Okay, there are two principal components, PC1 and PC2. So PC1 is actually called the primary component and PC2 is called another principal component that is orthogonal to PC1. PC1 is called primary principal component and PC2 is called second principal component orthogonal to PC1. Orthogonal to PC1. Getting the point? So अगर मैं बोलूं कि यहां पर जो डेटा का डायमेंशन है वो PC1 हो गया और PC2 हो गया, तो कौन सा ज्यादा इंफॉर्मेशन हमको कन्वे कर रहा है? PC1 ज्यादा इंफॉर्मेशन कन्वे कर रहा है या PC2? Which one? Tell me. Obviously PC1. PC1 because it is the primary principal component. It is the primary principal component. So PC1 is the primary principal component which explains the maximum variance in the data set. Maximum variance in the data set. तो डेटा को अगर मल्टी डायमेंशनल से अगर हम लोग डायमेंशन रिड्यूस किए हैं तो PC1 और PC2 के अलोंग में हमारा इंफॉर्मेशन अभी भी स्टोर्ड है, जिसमें से मैक्सिमम और मेजॉरिटी अमाउंट ऑफ इंफॉर्मेशन स्टोर्ड है हमारा PC1 के पास. That means PC1 is conveying or sharing us the most highest variance. Okay, the PC1 has captured the most of the variance of the data set. Okay, they have given the direction also, they have given the magnitude also. Okay, because we know that principal components are orthogonal projection. Orthogonal projection का मतलब क्या होता है? Perpendicular prediction. Perpendicular projection. So orthogonal projection or perpendicular of data into a lower dimension space. So high dimension से data को low dimensions में reduce कर रहा है. So PCA क्या है? PCA is actually used to reduce the number of dimensions in data. Okay, it can also be helped to resize a data. It can be used to resize an image. Okay, it can be used in analyzing the stock market price because बहुत सारे features जाते हैं ना वहां पर. It can help find the patterns in a high dimensional data set, and that's it. That's it. Okay, getting the point? Getting the point? Have a look at this. Just have a look at this. So the first one actually maximizes variance of blue points, and the second one basically minimizes residual. Okay. Theory part, is it clear? Is the theory part clear to everyone? Got it ना? चलिए ठीक है. ओके, अच्छा ठीक है, 2 मिनट का ब्रेक ले सकते हैं? ठीक है. I actually means explain किया ना. I just need to drink water. Just give me 2 minutes, not more than that. 2 minutes.
Okay, sir.
Hello.
Yes, sir.
Yes. Yeah, let's start.
Sir, I have one query, sir.
Yes, Rohit. Rohit bolo.
Sir, suppose I have one data set. It has
Hmm.
35,000 row and suppose 550 columns.
Ore
And the
baba.
column, yes, sir.
Huh.
Yes, sir. Human posture detection in Kaggle. Sir, sir, the columns names are very means XY axis, XYZ axis. Suppose this. Sir, is there any possibility to reduce the dimensionality and
Yes,
because
yes,
we cannot.
yes, yes. I will show you. Rohit, I am giving the answer to your question. Okay? Just give me,
Okay, sir.
I will take this half an hour to explain this, half an hour, 45 minutes I require to explain this, but I will explain, I cannot explain this through theory. We have to show one practical. Okay, so one practical. In the meantime, I just now founded one data set. See, credit card customers, credit churning customers, credit card customers. See, this data set. This is the data set. This has got data set size is 2 MB, so I am basically download 2 MB. See, it's getting downloaded. Very good. Downloaded. What are the columns? See, this data set has got 23 columns. Huh? 10 integer, 7 decimal, and 6 string. Okay. So, columns. What are the columns? Columns. Yeah, see, the first is actually column is actually the client num. What is client num? Client num means client number, unique identifier of the customer holding the account. Okay, this is a credit card, bank churners.csv credit card data set. uh, at reason underscore flag, internal event means customer activity variable. If the account is closed, then 1, else 0. Achha. Customer age, gender, dependent count, number of dependents, education level, one is high school, college, graduation, whatever, marital status, married, single, divorce, unknown, ओ बाबा रे. ठीक है. इनकम कैटेगरी ये देखो डॉलर में है. कार्ड कैटेगरी ब्लू, सिल्वर, गोल्ड, प्लैटिनम, कितना कुछ होता है बाबा रे. मंथ्स ऑफ द बुक माने पीरियड ऑफ रिलेशनशिप विद बैंक. तो इस तरीके से देखिए बहुत सारा कस्टमर यहाँ पर दिया हुआ है हमारा. ठीक है. 23 कॉलम्स वगैरह है. इस तरीके से कुछ कुछ कॉलम्स यहाँ पर दिया हुआ है. 10 ऑफ 23 दिया था ना, हमको यहाँ पर सिलेक्ट ऑल करना पड़ेगा. सिलेक्ट ऑल करके यहाँ अप्लाई करना पड़ेगा. गेटिंग द पॉइंट. तब जाके सारा का सारा कॉलम हम लोग को दिख जाएगा यहाँ पे. रुकिए. हाँ, ठीक है. डिपेंडेंट काउंट, मैरिटल स्टेटस. अच्छा, इनकम कैटेगरी, कार्ड कैटेगरी, मंथ ऑन बुक, टोटल रिलेशनशिप काउंट, month inactive 12 month, contacts count 12 month, number of contacts in last 12 months. This each and everything has been given. Credit limit, limit on the credit card, total revolving balance in the credit card, open average open to buy credit license line, total amount charge, total amount transaction amount, change in transaction amount, total transaction amount, total transaction count, total transaction count, टोटल सिटी चेंज में चेंज ऑफ ट्रांजैक्शन का बहुत कुछ यहाँ पर दिया हुआ है. समझ में आ रहा है आप लोग को? डेटा सेट सबाई बुझते पारছো? क्लियर हो रहा है सबको डेटा सेट? डियर एवरीबॉडी, डेटा सेट क्लियर हो रहा है आप लोग को? इज इट क्लियर द डेटा सेट? दिस इज बेसिकली एक्चुअली a data set of a credit card of some country. Okay, that I have downloaded from this kaggle.com. It has got around 23 features. Clear na data set? Wait, I am sending this data set. डाउनलोड्स में archive2 में था ना, archive2. So I will extract here. अच्छा, bank churners, BANKCHURNERS, bank churners. Okay, bank churners. So I will basically close this. It was basically GIS class 7. Now I will go for GIS class 8. Wait. GIS class 8. Okay, JS class 8. So first of all, I need to upload the data. Bank journals. Bank journals.csv. Uploaded. Client name, see all the data set has been given total. Got it na? Hello everybody, clear
Sir,
na?
got it.
Got it na? Data set is very
Yes, sir.
good. It's very nice data set. So let's move ahead. Let's start. Why
So
shall we
here what we
wait?
are predicting basically.
I will tell. First, I will go for the dimension. Okay, I will
Okay,
go
sir.
for the dimensionality reduction. Then I will apply any one of the algorithm and I will show it to you. Okay,
Okay, sir.
Darshan. But जो भी मैं आप लोग को बताऊंगा एकदम 100% क्लियर होगा, 100%. देखिए, ठीक है. Now, principal component. Okay. They are telling that this is actually a data set of 10,000 customer. 10,000 customers. Okay. तो सबसे पहले ये 3 तो रहेगा ही. From SQL under decomposition import PCA रन करते हैं भाई. Let's see. Import PCA. Okay, चलो. This is basically done. Okay, and one I need for standard scaling. Okay, so standard scaling के लिए मैं ये दो ले लेता हूँ. ट्रेन टेस्ट स्प्लिट तो हमारा रहेगा ही, उसको मैं कॉपी कर लिया और इसको भी मैं स्टैंडर्ड स्केलर डेटा को स्केल करने के लिए. बिकॉज बिफोर यूजिंग पीसीए वी नीड टू स्टैंडर्डाइज द डेटा ना. जैसे कल मैंने मेन मैक्स स्केलर लिया था, यहाँ पर स्टैंडर्ड स्केलर लिया हूँ. स्टैंडर्ड स्केलर लेकर मैं यहाँ पर डेटा को स्केल करूंगा. बेसिकली पीसीए के लिए स्टैंडर्ड स्केलर जरूरी है, स्टैंडर्ड स्केलिंग. ओके, अदरवाइज यू कैन नॉट परफॉर्म पीसीए. बिफोर परफॉर्मिंग पीसीए यू नीड टू स्केल द डेटा. Okay,
सर मीन मैक्स स्केलर लाइक 0 to 1 करता है, तो स्टैंडर्ड स्केलर का क्या रेंज है?
what is actually standard scalar? Okay, standard scalar basically it is used to resize the values. Okay, standard scalar is actually used to, यहाँ पर भी देखिए ज्यादा हालांकि कुछ डिफरेंस नहीं है. यहाँ पर भी ये भी क्या काम करता है, ये भी मीन को आपका 0 ही करता है और स्टैंडर्ड डेविएशन को 1 करता है बेसिकली. Okay, it also converts the mean to 0 and the standard deviation to 1, or we can say the unit variance. So standard scalar भी आपका मीन मैक्स स्केलर की तरह ही काम करता है. आप चाहो तो मीन मैक्स स्केलर भी यूज कर सकते हो. गेटिंग द पॉइंट?
ओके सर, पर सर पीसीए में क्या मीन मैक्स स्केलर लगा सकते हैं?
यहाँ पर बेसिकली हम लोगों ने वहां पर मीन मैक्स स्केलर क्यों किया था? वहां पर मीन मैक्स स्केलर हम लोगों ने क्यों किया था? मीन मैक्स स्केलर इसलिए हम लोगों ने किया था, वहां पर डेटा को हम लोगों ने नॉर्मलाइज किया था बेसिकली.
यस सर.
वहां पर डेटा को हम लोग नॉर्मलाइज किया था, यहाँ पर डेटा को हम लोग स्टैंडर्डाइज करते हैं. ये देखिए, नॉर्मलाइज किया था हम लोगों ने प्रेडिक्शन देने के लिए. ठीक है, और यहाँ पर तो हम पीसीए को लेकर प्रेडिक्शन नहीं देते, वो तो खुद अनसुपरवाइज्ड है.
ओके,
गेटिंग द पॉइंट? क्लियर हो रहा है? ओके, बेसिकली वहां पर हमारा देखिएगा क्या होता है. स्टैंडर्ड स्केलर हमारा क्या काम करता है, इट इज एक्चुअली रिमूविंग द मीन. मीन तो 0 कर रहा है ना, इट इज एक्चुअली रिमूविंग द मीन. और हमारा ईच फीचर वेरिएबल को यूनिट वेरिएबल, इट इज एक्चुअली मींस स्केलिंग ईच फीचर्स टू यूनिट वेरिएंस. ओके, ईच फीचर वेरिएंस टू यूनिट वेरिएंस. Getting the point? Now स्टैंडर्ड स्केलर जो होता है वो आपका नॉर्मल डिस्ट्रीब्यूशन फॉलो करता है, इसको कहते हैं स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन। मतलब मीन को जीरो कर देगा और बाकी जितना भी फीचर बचा है इट विल एक्चुअली स्केल द फीचर टू यूनिट वेरिएंस मींस 1। और मीन मैक्स स्केलर क्या करता है? मीन मैक्स स्केलर का काम होता है इट स्केल्स ऑल द डेटा और ऑल द फीचर्स इन द रेंज ऑफ 0 to 1, इन द रेंज ऑफ 0 to 1, ओके, और between -1 and 1 if there is any negative value in the data set। अगर नेगेटिव वैल्यू है डेटा सेट में तो उसको तो मीन मैक्स स्केलर 0 और 1 के बीच में नहीं कन्वर्ट कर सकेगा ना, सो दैट विल बी स्केल्ड बिटवीन -1 and 1। क्लियर?
sir.
Getting the point?
Yes, sir.
Okay, so this is basically the thing. So before starting PCA or starting the PCA, I told you that we will go for the normal distribution, and in Python or in machine learning, standard scalar is useful for normal distribution। स्टैंडर्ड स्केलर इज यूजफुल फॉर नॉर्मल डिस्ट्रीब्यूशन। आपने बोला सर क्या हम लोग मीन मैक्स स्केलर नहीं यूज कर सकेंगे? मीन मैक्स स्केलर क्यों नहीं यूज कर सकेगा? मीन मैक्स स्केलर may be used, okay, when you have a better knowledge of the upper and the lower boundary। अपर एंड द लोअर बाउंड्री मतलब जैसे कलर पाइथन जो है वो आरजीबी नहीं बीजीआर फॉलो करता है, बीजीआर। और आरजीबी का कलर कांस्टेंट क्या था? कलर रेंज क्या था? फ्रॉम 0 to 255, रिमेंबर, फ्रॉम 0 to 255 वाज द रेंज ना, 0 to 255, 255। अच्छा प्रीवियस एग्जांपल देखिएगा, प्रीवियस एग्जांपल when we were actually giving the prediction for that Kerala flood prediction, we actually knew the range of the data na, we knew the range of the data, that's why you used mean max scalar। so where the upper boundary and the lower boundary are well known, there you basically use mean max scalar। or if you have don't know information about the upper and the lower boundaries, then simply go for standard scaling, because it actually does what we know that standard scaling mean को जीरो करेगा और बाकी का जितना भी डेटा है, ठीक है, उसका यूनिट वेरिएंस कर देगा, rest डेटा को it will scale to unit variance। got it? when to use scalar standard scalar and when to use what to say min max scalar?
Yes, sir.
okay, getting the point? that's it। मीन मैक्स स्केलर ये हर एक वैल्यू को ट्रांसफॉर्म कर देगा बिटवीन 0 and 1 और विद इन द रेंज ऑफ 0 and 1। हर एक वैल्यू को ईच एंड एवरी वैल्यू विल बी ट्रांसफॉर्म्ड बिटवीन द रेंज ऑफ 0 and 1। ओके, और स्टैंडर्ड स्केलर ये भी क्या करता है आपका, ये आपका यूनिट वेरिएंस 1 करेगा और मिनी को करेगा 0, मींस ये डेटा को नॉर्मलाइज करेगा बाय सब्ट्रैक्टिंग द मीन एंड डिवाइडिंग बाय स्टैंडर्ड डेविएशन। इसीलिए स्टैंडर्ड स्केलर इज यूज्ड फॉर नॉर्मल डिस्ट्रीब्यूशन जहां पर हमारा अपर बाउंड्री लोअर बाउंड्री का कोई नॉलेज नहीं है हमको, वी डोंट नो। ओके, दैट्स इट। चलो let's start। so this was basically our concept। so I have been using the standard scalar over here, I've been using the standard scalar। now what is our next task? The next task is basically to do what? We have to read the data,
Import data.
yeah, read the data set, run this, read the data set। so we have read the data set basically। see, ये बाबा रे, ये क्या हो गया? ओ इतना डेटा मिसिंग है, ओके, इतना डेटा मिसिंग है, ना डेटा तो मिसिंग नहीं है, इस डेटा मिसिंग। what's going on? again we have to change the data set, but let me see first।
Sir, that is the column
कॉलम्स
name,
का
I
नाम,
think.
the कॉलम्स का नेम सर इतना बड़ा बड़ा है सर, इसीलिए वैसे दिखा रहा है वहाँ पे।
तो एक काम करते हैं ना, लास्ट का 2 कॉलम को हम ड्रॉप ही कर देते हैं। लास्ट का 2 कॉलम तो हमारा किसी काम का नहीं है, ठीक है। ये लास्ट का जो 2 कॉलम है,
सर
ये
कॉलम
तो
नेम चेंज कर दीजिए सर।
कर ही सकते हैं, कर सकते हैं, कोई दिक्कत नहीं है, कोई प्रॉब्लम नहीं है। लेकिन आप हमको बताइए लास्ट का 2 कॉलम का काम क्या है? विल इट हेल्प अस इन एनी वे? वो तो नेम बेस्ड क्लासिफायर से कितना वैल्यू निकला है उसको दिखा रहा है। सी, नेम क्लासिफायर, attrition flag, card category, it is showing that 0.9, this value is of no use. Okay, drop
Yes
these
sir,
two
you
values.
can drop.
You can drop these two values. हटाइए, not required. अभी परफेक्ट हो गया हमारा डेटा सेट?
Yes sir.
ठीक है, वो यूजलेस था, यूजलेस। df.shape, okay, 10,127 row and 21 columns है। It has got this much rows and columns. Okay, it has got this much row and column. Now this is actually complete. This task is basically complete. Now next is let me first see basically what is actually the level, basically means what are actually means how much we can basically contribute to this. Wait. It's got a lot of columns. Is there. So first we need to analyze. Okay, getting the point. We need to analyze. If you don't analyze now, then it will, I don't think it's going to work. Basically we have to analyze first. Okay, I don't know anything about this data set, basically getting the point. I have no idea about this. Let's start. Wait, first let me analyze the columns. Okay, suppose this education was first, na? Education equal to pd.data frame df यहाँ पर कॉलम का नाम क्या है? एजुकेशन लेवल df education level dot value underscore counts. So it will give the counts, value underscore counts. Okay, so value underscore okay. तो value underscore counts, वही मैं सोचूं क्या गलती है, value underscore counts. So inside education in a data frame the value underscore count is actually stored, and from the data set I will take the unique values only. Total values are count how much I don't know. Okay, and then I will take the unique values. Unique. Okay, I will count the unique values. Okay, after the similarly I will take the income also, and I will count the income categories. I will take the income also and I will count the income category. Okay, income category. So all these things I have taken as. So in the education I have stored the education level. Education level is basically a high school, graduate. Okay, so how many total values are there? Value counts I have stored, and then I have taken the unique values inside labels edu. Inside income I have taken the income category, and I have taken how many income categories unique are there, that I have basically stored. Okay, that I have basically stored. Wait, I need to import Plotly graph objs as plotly.graph objs. Okay, plotly.graph objs नहीं है तो क्या graph underscore objs है? plotly.graph underscore objs है. ठीक है, so plotly here I will take plotly. Okay, plotly library for plotting the graph. 2D graph plotting, huh? 2D graph plotting, don't worry. Got it? Now inside the figure, again I have to take one type domain. Type domain. Okay, this is basically the thing. Rows equal to 1, columns equal to 2. Okay, 1 row and 2 column. We are going to make the figure. See these two lines, we need to give a name. We need to give to name. Proportion of education, proportion of income. Name error, next subplots is not defined. Make underscore subplots is not defined. Subplots. Make underscore subplots. Okay, make underscore subplots. If I run this, so this is running. Now if I run this, wow, where is the graph? Where is the graph? Where is the graph? Oh, I haven't plotted the pie chart. I haven't plotted. No, I have plotted the pie chart. I plotted the pie chart. Fig dot 3 fig tr3. I will just pass it over here, and similarly I will copy paste that, and I will make this column. No, I will make it as column 2 itself. Now let's see. This we are getting. See, so this is basically the thing. Okay, perfect. See, here are the colors, and here are basically the incomes, the education, the high school. If you take on this, it's graduate. If you take on this, uneducated. Take on this, unknown. Take on this, college. Take on this, postgraduate. This is doctorate. See, so the graph has been plotted. graph has been plotted. Okay, it's plotted basically. So produced by Plotly, and download the plot as PNG. If you want, you can download also by clicking on this. You can download. Plotly is excellent, basically. You require a lot of what to say, experience for working with Plotly. That's why I didn't show it in the first instance. But now you are highly means you have got a lot of knowledge, so you can use this Plotly. See. Getting the point? Darshan, Rohit?
Yes, sir, got it.
No problem, na? So here I just wanted to analyze this. Okay, I just needed to analyze this. Okay, because until and unless I analyzed, na, means I was not actually means pretty sure actually. Okay, so this is how I analyzed. Okay, and now we can do one thing. Now we can do one thing. We can basically go with this exploratory analysis is done. Okay, we should not go into all these things, we'll get bored. And now we will head into PCA. So for prediction purpose, we will actually assign X. Existing, where is actually our target? Existing customer target. Where is the target? Target. Marital status, income, category, month relationship, month count. Okay. Wait. Now, which one will be basically our let me see first 50 rows. Existing customer, a treated customer and existing customer. Can you see this? This is actually our target column. This attrition flag. This attrition flag is our target column. Okay, got it? That's what I wanted to see. Chalo, perfect. So here, suppose we will take the data set from 9 till 21. Let me assign the data set from 9 till 21 on the X, the features. Okay, on X feature. Getting the point? Let's assign from 9 till features. Okay, and this particular attrition flag, we will actually replace the value. Okay, we will actually replace the value of existing customer by 1. Okay, similarly I will take and I will replace it by 0. Existing customer, and what was the next? Existing customer and attrited customer. Okay, attrited customer. So existing customer, and here control V, attrited customer. Okay, attrited customer. Now I need to do what? I will basically standard scale the data. Okay, I will standard scale the data.
I had one question. So why you have taken 9 to 21? Means the features, means there are more features like.
Okay, so this customer age, gender, dependent count, all these are required. I don't think This is required.
Sir, in
Okay, sir.
credit card system, it may be required because
No.
suppose
So
for
if
below
you are telling,
21 age a customer
no
credit
problem.
card
So
will
if this is the if this is the 0th column, then 1st column, then 2th column. You are telling I'm taking from 2th column. No problem. See, okay.
So it will be 2 to 22 though, because there are 22. So if you take 21, then it will continue till 20, 2 to 20.
21 column, na? Okay. So I will take to 2 to 20. Okay. What is the last column? Acha, average. Okay. So these things are useful, but I don't think these things are useful. Customer is, but still you are telling I'm taking it. No problem. Okay. Fit transform. Fit transform mix. Okay. Now I have this. Oh, what happened? Could not convert float to.
Yes, sir. In categorical column, we have to make transfer in others.
See, this is not required basically. If you give a prediction, na, this gender is basically not required. Is gender required for prediction?
So gender is not required.
Okay. Is age required for prediction?
So age, sir, it is not that matter because age can be same for two customers and.
No. If you go for feature selection, na, these three are not at all dependent. See, these three are not at all required. Customer age, gender, and dependent count.
So also marital status also means sometimes it not required.
Marital status is also not required. Education level is also not required. They never ask you education level. They never ask you marital status. From here it is required. Income category. This one is required for category. Yeah, for income, for credit card. Yes or no?
Means for 7, from 7 it will be required.
From where, Darshan? 0, 1, 2, 3, 4, 5, 6. I should start from 7, na?
Yes, sir.
Yes, I will take him from 7. Chalo, 7 से मैं ले लेता हूँ. ठीक है? 7 से ले लेता हूँ. चलो run कराते हैं. Again giving the same thing. Acha, see income also. It is also in the dollar format. It is also in the dollar format. If I drop this income category, then this card category, again this one is in blue, green, red. That's why I took from 9. Okay.
Sir, but sir, income category is highly required column.
See, basically here we are actually, see, highly required column I can understand, but this is when you are going to take a credit card basically, right? When you are going to purchase a credit card. But here these people already have the credit card. So we are not at all predicting whether that customer is going to have a credit card or not. Then we would have taken this account, this income column into account.
Yes, means
Okay.
for how much, means what is the income of the credit card they require,
Exactly.
then we can.
Yes. And this, even if you take this column, na, income category, then also with this income category, you won't be able to predict whether that person will get the credit card or not, because here they have said less than $40K. So how much income? How much?
Yes, sir.
They
They
have
are
not
given the
given
range.
Exactly. They have given the range, but they have not given the value. This project, this particular people already have the credit card. They have the card category also. Okay. They have the card category also. They are not going to take or purchase any credit card. That's why if you don't have the income column, na, Rohit, don't worry that no, this is going to affect. That's why I saw that.
Sir, if we convert it into integer value, then
How you will convert it into integer value? For less than 40K, what you will put? What you
sir,
will put?
if we take some threshold value for that.
No, we cannot take threshold value. This is absolutely wrong. If I tell that your income is below 50,000, okay, here your income can be around 24,000. 24,000. A person who works in MNC, okay, their income is around 18,000 also. They earn 25,000 also. They earn 30,000 also, 32 also, 45 also, 50 also. Now, what threshold value shall I take?
Yes, so we cannot take a particular value.
threshold value will be taken if there had been some missing one, na? But they have generally given there is no such missing value. Getting the point, Rohit? What threshold you will take? What threshold?
Yes, sir. Yes, sir.
If there has been missing value, then definitely some threshold I would have taken. I find out the mean. Okay, 60 to 80, there would be around 70. Or 60, 80 plus 60, 140, na? 140. 140 to there would be 70 is basically the mean. So I would have filled it with that. Those where it is less than 40k or less than 30k or less than 20k. Okay, if there is a variation, then again this data set means here income is not at all genuine. Okay, so we cannot work with this income column. So I am taking here with 9 and see my problem is solved. See, I am promising you nothing will happen. Believe me, I have got so much day experience. Nothing will happen. Okay. And on the y-axis, I will take the flag, basically flag, attrition flag. So on the x-axis, I have taken all the features. On the y-axis, I have taken the target. I've taken the target. That's it. Okay. Now, if I will go for my data set, where is my actual data set? df.head. So you can see this attrition flag existing customer, it has been converted into 0 and 1. See, this attrition flag has been converted into 1 and 0 also. Getting the point? Rohit and Darshan, everybody getting the point? If till here it is clear, then okay, then only tell me, I will proceed.
Yes, sir. Clear.
Okay, sir. Clear, sir.
Clear? Now, here I will start using only first 2 principal component. Then I will take first 3 principal component. Then I will explore to 4 principal component. Because 9 till 21, how many columns are there? 12, na? 12 columns are there. So first of all, I will take 2 principal component, then I will take 3 principal component, then I will take 4 principal component, and I will show you basically how much you are gaining and how much you are losing basically with all these principal component features. Okay, I will show you each and everything. Just try to understand the concept. So if here I take, suppose a variable PCA equal to PC, if we create the model, okay, n underscore components, NENTS, nents equal to 2, n underscore components equal to 2. Now PC equal to PCA dot fit underscore transform. So fit underscore transform what? X. Fit underscore transform X.
So transform it will be a for.
Transform, acha, yes, form. Sorry, my mistake. So transform X, and here principal df, suppose principal df equal to pd dot data frame, data equal to PC. Inside PC we have transformed the data, and I said that n components I have taken 2, means I'm going to make a transform into what? I'm going to take 2 dimension, 2 principal components. So the name of the first one is going to be, suppose PC1, and the name of the second column is going to be PC2. Okay, so I have reduced from 21 to 2. Final df equal to pd dot concat, pd dot concat. Okay, inside this I am going to take this principal df. I'll copy this, I'll paste it over here. Principal df and df, I'm going to take attrition flag. This attrition flag is not going to be get converted, na? Okay, wait. Axis equal to 1. Axis equal to 1. So final df dot, अभी इसको रन करते हैं. देखो, so देखो टोटल हमारा x, ये x it has contained 19 features around, हमारे 12 feature ना, 12 feature is converted into C 2 features. So dimensionality has reduced from 12 to 2. Now see, So name of the first one PC1, name of the second column PC2, and the target over here. See, target I have concatenated with it. In the concat, it requires two parameters. The first parameter is the actual data, and the second one is the column that you want to concatenate. See, just try to understand.
Sir, what is PC1 and what is PC2?
I have given one column name. I have given one column name, PC1 and PC2. You can give anything. I have reduced the data set from 12 to 2. Dimension of the data was basically 12, not 12 feature. Na? I have reduced to 2 feature.
Yes, sir.
2
Yes,
feature.
sir.
So I have given a column name, anything. You can give anything you feel like. Okay.
Yes, sir.
Yes, sir, got it.
Got it now? Yes. So this is basically the concept. This is basically the concept. Now, this is basically done. So no problem with this. No problem with this. This is basically complete. Okay. Now I will go for logistic regression. Okay, I will go for logistic regression. Logistic regression. Huh? I am not doing anything. I will take logistic regression basically. You will say, no, sir, how you are giving the prediction? I will take logistic regression basically. So for logistic regression, I require one X and I already have the Y. So I will apply logistic regression here to give the prediction. See. Logistic regression. From sklearn.linear_model, import logistic regression. And one what we wrote, import train_test_split. I will copy from the other one. Okay. And here I will have PC. This PC1 and PC2 I need to copy from here. PC1 and PC2. This is PC1 and PC2. Right? PC1 and PC2. Right? And where we have the what to say? The target, attrition flag. So here we have the target column. See. So on X we have the feature, Y we have the target. This was the thing now. Yes or no?
Yes, sir.
Right? Very good. Now.
Yes, sir.
Yeah. So the data set is basically X_final for X and Y_final for Y. This data set is actually test size is 0.3. Means 30-70 have split it. You can take it to 20. Okay, according to your choice. Right. So here the data set is large. That's why you have taken. Now the model
So
is
what is a
basically
random state?
randomly you want to divide. What is the use of random state? Do we need random state?
So we want to divide randomly. So
Why? We did here random state is not required, na? The feature is already converted. If you are selling random state, sir, I will take random state. Even I can take. Let me find out the accuracy. After that, I will take darshan. Okay.
okay, sir.
Okay, no problem with that. I will take. Don't worry. Here, random state is basically not required. Not required. Build the model. Build the model. Logistics.fit. So here in logistic.fit, what I'm passing? I'm passing xtrain comma ytrain. Okay, I'm passing xtrain comma ytrain, right? X_train comma y_train. Let me run. Null df is not required. अच्छा DF let me run model is trend. See, model is trend, right? Our model is trend. Okay, and now what I have to do? I have to give the prediction. I have to give the prediction, and then I have to go for what? I have to go for the testing part. So what is my accuracy? 85%. 85%. Now I will take the random state. 42. It's decreasing. See. Okay, for 0 it's increasing, for 1 it's decreasing. So shall I take 0 ना? तो सेम थिंग तो यदि हम अगर हमें पर रैंडम स्टेट नहीं भी देते हैं, कितना 84 आ रहा है. अच्छा, अगर रैंडम स्टेट देते हैं तो 86 आ रहा है. ठीक है, चलो रैंडम स्टेट ले लेते हैं, बहुत अच्छा है. ऐसे भी हम लोग को तो एक बार चेक करना ही पड़ता है रैंडम स्टेट वगैरह को लेके. ठीक है, इट्स गिविंग 86% एक्यूरेसी. It is giving 86% accuracy, right? Yes or no? Clear? No problem? Hello? Hello? Hello?
Yes, sir. No problem, sir.
No problem. ठीक है. Now, I will copy this whole code. Again, I will copy this code. I will paste it over here. Here I will change the n component to 3. And here I will make PC3. Got it? Run this. So we have 3 principal component. 3 principal component. Okay? 3 principal component. Now again, let me create this model. So data set is basically okay, logistic. It's made, na? Yeah, data set is basically divided into.
Sir, in the X final, you have to take PC3, then only.
Where?
Sir, in the X final, you have to take PC3.
I have to copy this whole code. I have to paste it over here. PC2, PC3, right? So that's it. Done now. Run this logistic regression trend. Now I will copy this. Paste it over here. 88%. 88%. Slightly increased. It's increased. Okay, 88%. Now, so 3. I have to do one thing. It's done till 3, na? So I'll copy this again. Till 4 I will go, huh? Till 4, not more than that. 4. 4. Okay. Now, logistic. I'll copy this again. Paste it over here. 4. Logistic regression. Okay. Again, I will copy this. Paste it over here. So it was 88.25 previously, and now it is 88.28. So much more. There is no much more increase. Okay. So I will not go for 5. So this is done. Complete. Okay. This is done. This is done. This is done. So I have made up some slight mistakes. You know what are the slight mistakes that I have made? I must take here score 3. I will take here score 3. Okay, and here I must take some different variable, huh? Different variable, score 4. So something like this. So that's it. That's it. Done. Completed. No problem. No problem. Na? Now I will take one variable. Suppose inside this list score underscore 2 comma score underscore 3 comma 4. I've just converted the whole thing into list. Right? I converted the whole thing into list. And after converting it into list, I have to do one. Yes? Any problem? Any problem? Hello? Do anybody has any problem, any question? Okay, so after that we need to go for bar plot. So for plotly for bar plot, import plotly.ex, plotly.express as ex. Okay, we need the express. So ex.bar. So what we basically need inside this we basically need to pass the value for y first. Okay, the value for y first. Getting the point? Here single line prediction will basically we write. So for y we are having this is scores. Okay, and for x will pass PC1, PC2, PC3, right? And then we'll give title equal to how much? Accuracy.
It will be PC4 now. There are 4, so.
Oh, 4 na. So PC1, PC2, na to. PC, then it will be PC2, then it will be PC3, and here it will be PC4, right? Yes or no? Accuracy comparison. See, PC2, PC3, PC4, accuracy comparison done. Whoa, excellent.
So why you have taken PC1 is not here?
PC1 क्यों रहेगा? PC1 हमारा बेसिकली क्या है? PC1 का मतलब हम लोगों ने किया ही क्या था PC1 में? देखिए हम बताते हैं आपको, ठीक है? ये PC1 और PC2 बेसिकली इट मींस व्हाट? वी हैव 2 PC ना, 2 principal component ना. Okay, so basically if you want a better set, you change this to तो मालूम था कंफ्यूजन होगा. 2 PC कंपोनेंट हम लोगों ने 1 कभी लिया था? 1 तो लिया ही नहीं कभी, ठीक है?
Okay, sir, got it. Yes.
2 PC component, 3 PC component, 4 PC component.
Yes, sir, got it.
So ये प्लॉटली देखो, ये प्लॉटली का बहुत ही इंटरेस्टिंग होता है. देखो इधर उधर आप ग्राफ को सरका भी सकते हो. देखो वेरी इंटरेस्टिंग प्लॉटली जो है ना, वेरी इंटरेस्टिंग. बट फॉर वर्किंग विद दिस यू रिक्वायर अ लॉट ऑफ एक्सपीरियंस, यू नो. सी इट, इस पे कर्सर ले जाओ. सी इट्स टेल y is 0.88. इस पे कर्सर ले जाओ. 0.88 something like this. Score 3, it's score 2, score 2, score 3, score 4. Let me run all these things. इसको ऊपर ले जाइए, अब ले जाइए. 86, 88, 88.28, 88.25, 86.31. That's it. Done. Here our dimensionality reduction is complete. PCA, logistic prediction. PCA, logistic, principal component analysis, logistic and prediction. This is how we reduce the dimensionality of the data set. देखिए क्लियर हो रहा है सबको? इज इट क्लियर टू एवरीबॉडी?
Sir, can you share this IPYNB file and the data set?
Each and everything I will share. Each and everything I will share. Wait, I'm sharing.
And also there's a tutorial also, PCA tutorial you have not shared.
Yeah, I'm sharing the PCA tutorial. Sharing. sharing the PCA tutorial. Wait. Today I think we saw something extraordinary, isn't it? इतना पता था आप लोगों को कितना कुछ होता है मशीन लर्निंग में?
नो सर।
ठीक है, तो बेसिकली अभी कल मैं 2-4 प्रोजेक्ट्स करवाऊंगा। फर्स्ट हाफ में कुछ प्रोजेक्ट्स करवाऊंगा, सेकंड हाफ में कुछ प्रोजेक्ट्स करवाऊंगा, ठीक है, डोंट वरी, उसको लेके बहुत इंटरेस्टिंग प्रोजेक्ट हो जाएगा हमारा। ओके, जीआईएस क्लास, ये कौन सा क्लास था? ये जीआईएस क्लास 8 था ना, पीसीए लॉजिस्टिक था, पीसीए लॉजिस्टिक, PCA logistic. So I have sent the data set, I am sending this IPYNB file, and I am sending the PCA tutorial that I have made for you. Okay, that's it. चलिए, so I think आज के लिए इनफ है, क्या बोलते हैं आप लोग? आज के लिए काफी है ना इतना? Is this enough for today? आज के लिए इतना है, काफी है? चलिए अटेंडेंस ले लेते हैं। So अच्छा, अनुषा बेरा, अनुषा बेरा,
Yes, sir. Yes, sir.
ओके, जैक सिद्दीकी, श्रेष्ठा पोद्दार,
Present, sir.
ओके ओके, सृष्टि,
Present, sir.
ओके, आदित्य नारायण, आदित्य नारायण, भावतो सरकार,
प्रेजेंट सर।
अच्छा, बुधा,
प्रेजेंट सर।
ओके, देवज्योति, प्रेजेंट, देवोपम, देवोपम प्रेजेंट, अच्छा, दीपंकर खटुआ तो नहीं, अच्छा, दीपी रंजन प्रेजेंट, ईमान नहीं है, अच्छा रुकिए एक सेकंड, रुकिए होल्ड कीजिए। ओके, दीपी रंजन प्रेजेंट আছে, এমান কল্যাণ মাহাতো তো नहीं है, अच्छा कौशिक देवनाथ, कौशिक प्रेजेंट আছে, प्रेजेंट আছে, प्रतीक, प्रतीक
हाँ सर, प्रेजेंट प्रेजेंट सर।
प्रेजेंट है, बहुत अच्छा है, अच्छा प्रतीक्षा घोष प्रेजेंट আছে, ठीक है, प्रत्यय प्रेजेंट है, प्रयास, प्रयास আছে, प्रयास, अच्छा ऋषि हलदार, ऋषि हलदार प्रेजेंट আছে, अच्छा रोहिश, रोहिश আছে, रोहिश আছে,
প্রেজেন্ট স্যার।
रूपम सरकार, ठीक আছে रोहिश, ठीक আছে रूपम सरकार আছে, संचिता
Present, sir.
अच्छा संचिता আছে, তারপর আছে সপ্তর্ষি সেন, সপ্তর্ষি সেন, আচ্ছা দাঁড়া, সপ্তর্ষি সেন আছে, আচ্ছা সায়ন চক্রবর্তী, সায়ন চক্রবর্তী, সায়ন চক্রবর্তী, শেফালিকা, प्रेजेंट है, ठीक है। सौमिक, सौमिक तो एब्सेंट আছে, सौमिक एब्सेंट আছে। अच्छा, शुभम चौधरी,
प्रेजेंट सर। प्रेजेंट सर।
ठीक है, शुभम चौधरी। अच्छा, सुमन ठाकुर नहीं है। सूर्यदीप रॉय, सूर्यदीप रॉय, त्रिदीप्त আছে আছে আছে, ঠিক আছে, ত্রিদীপ্ত আছে। ওয়েট জাস্ট আ সেকেন্ড। ओके, तो ठीक है। गार्गी देखना, तुम्हार नाम এখন কল করিনি তো আমি। आकाश है, आकाश है। आनंद मोहन झा, आकाश,
प्रेजेंट सर। आनंद झा।
आनंद मोहन झा,
प्रेजेंट सर।
ओके। अंगना दास,
Present, sir.
ओके। अनिकेत मिश्रा,
यस सर।
अरिंदम सिंह,
यस सर।
औरित्र घोष,
यस सर, प्रेजेंट।
अरविंद कुमार मिश्रा, ओके। आयुष मिलन,
यस सर। आई
ओके। बिलाल अहमद, दर्शन प्रेजेंट, दर्शन प्रेजेंट। गार्गी देवनाथ प्रेजेंट, जीत साहा प्रेजेंट,
प्रेजेंट सर।
मेघा प्रेजेंट,
Yes, sir.
मोहित सहाल, ओके। मोहित सहाल, मोहित देखो फार्स्ट हाफे এসেছে, এখন আসেনি। पंकज घोष,
यस सर।
पंकज
पंकज घोष।
पंकज घोष प्रेजेंट। प्रभात कुमार,
प्रेजेंट सर।
ठीक है। राकेश रोशन,
यस सर।
राकेश, ओके।
यस
रेशमी,
सर। यस सर।
ओके ओके। राकेश रोशन प्रेजेंट, प्रेजेंट।
Yes, sir.
रेशमी,
Present.
ओके।
Present, sir.
रोहित तो प्रेजेंट আছে।
Yes sir, present.
रोहित प्रमाणिक আছে, আর রৌনক প্রমাণিক, রৌনক প্রমাণিক নেই মনে হয়। संजना रानी, ओके। सप्तश्री कुंडू, सप्तर्षि कुंडू, सप्तर्षि रॉय, शायनबाग,
प्रेजेंट सर। साइनबाग।
शायनी घोष,
Present, sir. Shiny Ghosh.
ओके। शायंतन घोष नहीं। श्रेय कुमार बर्नवाल,
प्रेजेंट सर।
ठीक है। सिमरन कुमारी,
Present, sir.
नेहा गोस्वामी,
Yes, sir. Present.
ओके।
Present, sir.
श्रुति सामंत, श्रुति सामंत, श्रुति
Present, sir.
सामंत, श्रुति सामंत, ओके ओके। सौरभ बाग আছে, सौरभ बाग नहीं। सुभाषिस पॉल, सुभाषिस पॉल नहीं। सुधोजित दे नहीं। सुमित कुमार, सुमित कुमार
सुभाषिस पॉल प्रेजेंट আছে।
सुभाषिस पॉल प्रेजेंट আছে। দাঁড়াও দাঁড়াও
यस।
দাঁড়াও। सुभाषिस पॉल হ্যাঁ প্রেজেন্ট।
It was taking to time to unmute it.
ओके, you are no problem, no problem, it's okay, present,
Okay.
present.
Thank you sir.
You are present, Subhasis Paul, present every day, you are present every day, don't. Okay, सुमित कौर present, सुमित कुमार present है। सूरज माइती है, सूरज माइती,
यस सर। सूरज माइती।
सूरज माइती है। अच्छा, सूरज माइती हो गया। वरदान सासत, वरदान सासत नहीं। रिद्धिमान घोष प्रेजेंट। सूरज माइती प्रेजेंट है, प्रेजेंट है सूरज माइती। ठीक है, सबका अटेंडेंस हो गया? चलिए
सर निखिल कुमार।
निखिल कुमार रुकिए,
रिद्धिमान प्रेजेंट আছে।
है रिद्धिमान प्रेजेंट আছে। निखिल कहाँ छूट जाते हैं आप? निखिल कुमार प्रेजेंट है
ठीक है सर।
एकदम प्रेजेंट, ठीक है। रिद्धिमान घोष प्रेजेंट। और कोई है? कोई है और जिसका अटेंडेंस कॉल नहीं हुआ है? हेलो, एनीबॉडी? सबका कॉल हो गया है? चलो ठीक है, ठीक है, चलिए चलिए, आज इतना ही रहेगा अभी। ओके चलो, टेक केयर एवरीबॉडी। हाँ
सर वन
Take care.
क्वेश्चन।
हाँ बोलो, बोलिए दर्शन, बोलिए।
सर लाइक ये ट्रेनिंग खत्म होने के बाद हम लोग का मतलब क्या एक एग्जाम भी होगा क्या?
देखिए ये ईच एंड एवरीथिंग जो है ना, मतलब हाँ एग्जाम वगैरह आपको शायद देना पड़ेगा एक, तो वो एक्चुअली है ना, वो ग्रुप में देखिएगा जीत सर है, ठीक है।
Yes,
जीत
sir.
सर है ग्रुप में, देखें आप। हाँ तो जीत सर ना ईच एंड एवरीथिंग, जब जब आप लोग का एग्जाम होगा, कब सर्टिफिकेट मिलेगा, क्या मिलेगा, सब वो ग्रुप में पोस्ट करते रहेंगे। आप लोग का
और हम
सब
लोग
कुछ, आप डॉक्यूमेंट वगैरह आप लोग को मिल जाएगा, सब कुछ क्लियर हो जाएगा, ठीक है। उसके बाद ही कोई ग्रुप से लेफ्ट करेगा या फिर कुछ भी नहीं। तो ऑलवेज कोई भी क्वेरी के लिए ओपन है, आप उनको सिर्फ सर को ग्रुप में एक बार टेक्स्ट कर दोगे ना आप लोग ग्रुप में, तो बस वो रिस्पॉन्ड कर देंगे, ठीक है।
और हम लोग को सर क्या प्रोजेक्ट भी सबमिट करना होगा क्या लास्ट में? एक प्रोजेक्ट मतलब कुछ ऐसा?
नहीं नहीं, प्रोजेक्ट तो मैं बनवाऊंगा, ठीक है। वो प्रोजेक्ट आपको सबमिट करने की जरूरत नहीं है बेसिकली, ठीक है। वो प्रोजेक्ट को आप अपने पास रखिए, मैं डॉक्यूमेंटेशन का फॉर्मेट भी आपको सबमिट करूंगा, ठीक है। उसके अगेंस्ट में डॉक्यूमेंटेशन बना के आप रख लीजिएगा, ठीक है।
अच्छा
कि
मतलब हम
कभी
लोग
आप
प्रोजेक्ट पे सबमिट नहीं करना है?
नहीं नहीं नहीं, कुछ सबमिट नहीं करना आपको, कुछ सबमिट नहीं करना थी, ठीक है।
अच्छा,
अगर बोला जाए आपको तो ही सबमिट कीजिएगा, अदरवाइज मैं जो प्रोजेक्ट करवा दूंगा आप प्रोजेक्ट अपने पास रखना, ठीक है। कि कुछ
ओके
भी इधर उधर ये करने की जरूरत नहीं है, ठीक है। सब कुछ है, मैं हूं, मैं देख लूंगा, ठीक है। आप टेंशन मत लो एकदम, ठीक है। चलो
ओके सर।
ओके, चलो थैंक यू एवरीबॉडी, चलो चलो ठीक है,
Thank you, sir.
थैंक यू थैंक यू थैंक यू।
Thank you, sir.
हाँ थैंक यू एवरीबॉडी, थैंक यू राकेश।